Hello, my name is You Jun. Today I'm going to go through my tutorial 10 for my engineering mathematics. So the question 1 of tutorial 10 is to evaluate the double integration of y sine x dy dx. So first we go to the integration of the y first, which is y squared sine x over 2 with the 0 to 1. Then you get the final answer of sine x over 2. Then we go to the integration of the x from 0 to pi over 2. The answer will be negative cos x over 2. Then substitute with the pi over 2 and 0. Then we will get 1 over 2. So the question 2 is the same of the double integration of y open bracket 1 plus x y close bracket from 0 to 3, then 1 to 2. So we go through the equation there. After the integration, there will be xy plus x squared y squared over 2. Then substitute with 0 and 3. You can get the answer of 3y plus 36y squared. Then integrate again with the dy from 1 to 2, and we will get 3y squared over 2 plus 12y cubed. Then substitute with 2 and 1 and get a final answer of 88.5. So the question 3 is to find the volume of solid bounded above the plane z equals to 4 minus x minus y. Then the rectangular of x and y. The x is 0 to 1 and y is 0 to 2. So this is the equation to find the volume. First, we integrate the z first from 0 to 1 with the dx and get the answer of 4x minus x squared over 2 minus xy. Then we integrate again with the y from 0 to 1 get the final answer 7 over 2 minus y. Then integrate y with the solution 2 to 0, then get the final answer of 5. So the question 4 is like the same. Go through the double integration of 1 over x cos y over x. So after the integration of the dy there, then we will get the answer of sine y over x. Then we substitute the x squared and 0, get the final answer of sine x, and integrate the sine x again with pi over 2 to pi, and get the final answer of 1. So the question 5 is to solve the double integration of d 4x plus 2 dA. And with the enclosed of the curve y equals to x squared, y equals to 2x squared, and y equals to 2x. So this is the graph, and the y equals to x, y equals to x squared, and y equals to 2x. So this is the area that the D region. So as we can see, the 4x plus 2 dy dx there, the y will be 0 to 2, and the x will be 0 to 1. So the d is the 0 to 2 and 0 to 1. So first we solve the y first, and we get an answer of 4xy plus 2y with 0 to 2. And we will get x plus 4, then dx 0 to 1. With 0 to 1, then we will get 4x squared plus 4x with the solution of 0 to 1 and get final answer of x. So the question 6 is to use the green theorem to calculate the integration of xy dx plus x squared xy dy. With the C is the triangle which from the 0, 0 to 0, 1, 0 and to 1, 2. So this is the graph of the triangle. So as you can see, there are C1, C2 and C3. The C1 is the y equals 0, this y equals 0. C2 is the x equals to 1, and C3 equals to y equals to 2x. So the y equals 0 is 0 to 1, then x equals to 1 is from the y 0 to 2, then the y equals to 2x is from 0 to 1. 1 to 0, sorry. So the C1 is 0 there, and after the integration there will be 0. The C2 will be integration of 0 to xy dx plus x cubed dx. Then substitute the dx will be 0. So the integration of y cubed dy y power 4 over 4 is the final answer. Then substitute with 0 and 2, then get the final answer of 4. The C3 is y equals to 2x. So the dy dx will be dy equals to 2 dx. Then substitute to the equation here. So from 0 to 1, x 2x squared plus 16x power 5 dx. And integrate them, get the final answer of 10 over 3. So the final answer will be 0 plus 4 plus 10 over 3. So that will be 22 over 3. So the question 7 is use the same, you apply the green theorem and calculate the equation here. Y cubed dx minus x cubed dy. As you can see, the C is the circle with the radius 2. So the C1, C2, C3, C4 are the same equation. X squared plus y squared equals to 4. So because of there are same equation, so we just need to calculate one C only. So I take C1 to calculate x squared plus y squared equals to 4. Then y will be sub 4 minus x squared. The dy dx will be 1 over 2, 4 minus x squared power negative 1 over 2 with negative 2x. So the dy will be negative x over sub 4 minus x squared dx. Then substitute that into the equation here, and we will get the integral of 0 to 2 with sub 4 minus x squared with power 3 dx minus x cubed minus x over the sub 4 minus x squared dx. Alright, then I let the x equals to 2 sine theta. The dx will be 2 cos theta d theta. Then the sub 4 minus x squared will be 2 cos theta. Then substitute into the equation and get the 2 cos theta power cube plus 2 sin theta power 4 d theta. It will be d theta. Then the 0 and sub over 2 is I let the x become 0, then I find the theta that will be 0 also. If the x will be x equals to 2, then the theta will be sub over 2. So we do the integration with from 0 to sub over 2, 16 cos power 4 theta plus 16 cos power 4 plus 16 sine power 4 theta. So I let the A equals to 16 cos 4 power theta and B equals to 16 sine 4 power theta. So I separate the cos 4 into the cos square. The cos square that I substitute with the 1 over 2 bracket with 1 plus cos 2 theta, then cos bracket with square. Then express that into 1 over 4 bracket 1 plus 2 cos 2 theta plus cos square 2 theta cos bracket. Then the 1 over 4 multiply with 16 get 4, and 1 plus 2 cos 2 theta plus 1, that the square here I substitute with 1 over 2 bracket 1 plus cos 4 theta cos bracket d theta. So elevate them and get 4 integration of 0 to pi over 2, 3 over 2 plus 2 cos 2 theta plus cos 4 theta over 2 d theta. Then integrate them and get 3 pi. So the b like the same, I let the sine 4 theta equals to sine square theta bracket square, and substitute the sine square theta into 1 over 2 bracket 1 minus cos 2 theta close bracket. Then the 1 over 2 with the square there, that will be 1 over 4. Then multiply with the 16 and get 4 here. Then 1 plus cos 2 theta square minus cos 2 theta d theta. Then substitute the cos 2 theta square into the 1 over 2 bracket 1 plus cos 4 theta close bracket, then the minus 2 cos 2 theta. And elevate them, get the 3 over 2 plus cos 4 theta over 2 minus cos 2 theta 2 cos 2 theta